Salutations, my fellow homunculi. Salutations. This is valid parentheses 20. This problem, wait, first time doing this problem, by the way, actually true. This problem, kind of difficult, not going to lie. But it's really good intuition for a lot of these problems where you have to kind of adhere to some set of rules, right? So you're going to get a lot of these problems in the future. There's a couple different ways to do it, but this way I think is the most intuitive, and you can, shimmy it for other solutions as well. So given a string S containing just the characters, and you can look at the characters here, opening bracket, closing bracket, and so on and so forth. It's basically just parentheses, curly brackets, and square brackets, right? Determine if the input string is valid. So we're returning a Boolean here. So open brackets must be closed by the same brackets. Kind of like when you're declaring a function in JavaScript, right? You can't declare a function like this. That doesn't quite look right, right? But you can also do some weird stuff like this, So those would still be correct. So we can also do something like this, right? So each of these things are closed properly, right? This would be false, right? Because a parenthesis is being closed by a bracket, right? So that's incorrect. So here we also have a this case right here. So it's good to read all the examples. Gives you a hint as to, they tell you some things here, right? But they don't really tell you to what depth, right? So example 4, you can really see, right, that a naive solution is not going to work here, right? So a naive solution, right? If you ever get a simple problem, you don't have to enforce order. You just have to match parentheses, right? You could just count, and they were all the same. You could just count the number of left parentheses and right parentheses. If you equals 0 at the end, right, that means there's no, so for every left parenthesis you'll add 1, for every right parenthesis you'll subtract 1, right? If you have 0 at the end, then they all close each other, right? But it doesn't quite work here, right? They all match each other here, right? But this right parenthesis is closing this square bracket first, right, which is something that we don't want. And this is also good, right? So you can see what a correct mapping looks like. So how do you go about this, right? So we're going to Sketchpad, right? And the intuition for this problem, right, is a stack. So I'm wondering why use a stack, right? So there are one or two reasons to use a stack. So when you have something like this, right, where you have to kind of go backwards to like let's just say the front of your your problem set really isn't changing, right? A stack is going to really lend itself to a lot of those properties, right? So when we iterate through the string, right, the front's not going to change at all, right? And we just want to know, right, when we're going backwards through the stack, we're popping elements off the stack, that we're preserving the order, right? Like the question wants us to, they must be closed in the correct order. So stacks help a lot with that. So what's the intuition for the algorithm, right? Going to iterate through the string, right? Iterate through the string. This is the string. 2 curly braces, 2 square brackets, another square bracket, right, and the wrong bracket, and the wrong parenthesis here closing the square bracket. So what is going on here, right? So what you can do is we'll iterate through the string, right? What we'll do is we'll only add to the stack. This is the key intuition. Only add to the stack opening curly brackets, right? And you'll see why in a second. So if we only add opening curly brackets to the stack, right, we're iterating through the string, right? I'm just going to say I is equal to 0 for now. So we're at the 0th index here, and I'll put the numbers above so it's easier to follow. Boom, right? I is equal to 0. So this is an opening curly bracket, right? We're going to add it to the stack, right? So boom, that's dope. We now have the opening curly bracket, right? So what we're going to do, right, is the next thing we're going to do, right, is we're going to check, right, whether or not, so to add, if we're only going to add opening curly brackets, right, we have to check if the symbol is an opening curly bracket, right, which implies that we're going to have a dictionary, right, where we can, or some method, right, that we know that this symbol, right, is an opening bracket, right. And so the first thing we have to do, right, is check if the opening bracket is there, right. So if that's the case, right, if we checked here and we added here, we go to this one, right, we see here, right, that this is our second case, right, that this is not an opening curly bracket, right? So if it's not an opening curly bracket, what should we try and do? So we should check the top of the stack, right, and see if the top of the stack's curly bracket, right, if its closing bracket would match this symbol, right? So in the dictionary, we're going to have to look it up and say, hey, what's the top of the stack? It's this item. What's its closing proper closing bracket? It's one of these. We check the symbol at 1, right? And it turns out it's correct, right? So what we do is we actually pop this off the stack. I don't have any eraser, so I'm just going to cross it off, right? And that's good. So then, right, now we're on I equals 2. So we only add opening curly braces, right? Opening brackets, right? So square is an opening bracket, and right, and then we go to the next case, right? We get here, right? So we only add opening curly brackets. It's not an opening curly bracket, right? So if it's not, right, does it close the most recently added opening bracket? If it does, we're gonna remove it from the stack, which it does. So now we go to the 4th index, right? So now we're gonna add parenthesis. We're gonna add another square bracket. So we're gonna add it to the stack, right? Let me redo that. We're gonna say, and then that's it for that iteration. Now we go to the 5th iteration. This is our final character, which is this right parenthesis. We're gonna say, hey, is this an opening bracket? It's not, right? So let's go to our second case. Does it close our most recent opening curly bracket? Open bracket, right? We look up what the proper curly bracket is, proper closing bracket is for this bracket. It's not a parenthesis, right? And we're like, wait, that's not it, right? So we go to our final case, which is else, right? If it doesn't close this, right, then we return false. Why do we return false? So this obviously is going to return false, right? Because they don't all match. Why would we return false there? It's because open brackets must be closed in the correct order. So this is how we're enforcing order with the stack, right? So we only add open brackets, and if we ever see anything that's not an open bracket, we'll try and close it. If we can't close it, right, then that means that it's not closing in the correct order, right? So we're trying to close this bracket with the incorrect bracket. So I'm gonna start on the code here. It's gonna be very similar, but so what's the same intuition we just kind of had on that sketchpad, right? We need a dictionary, right, to map opening, right, to closing brackets, and I'm gonna slide this over. All right, so we need a dictionary to map opening and closing brackets, right? And we need a stack to enforce order for the rules, right? So we have these two rules, we have to enforce it, right? And we need the stack to do that, right? And then we said, right, that we'd have to iterate. We'd have to iterate through the string, right? And then, like our two cases that we mentioned, right? If it is a opening bracket of some sort, right, add it to the stack, just like we said we would, right? Then we go to the next iteration. Well, if it's not an opening bracket, then let's see, right? If we look up this symbol in our dictionary and it's a closing bracket and it matches what's on the top of the stack's closing bracket, right? So if this symbol matches the top of the stack's closing bracket, right, then that's great. It means we found this opening bracket's buddy, right? So that's good. So we can just pop it off the stack, right? So we'll say stack.pop. So actually I'll make this else if to be more literal, right? Else, right? So this is, maybe we're working with something like this, right? So S is equal to open parenthesis, closing square bracket, right? So we added opening bracket, which is a parenthesis. Then we're looking at the square bracket. It's not an opening bracket. Okay, well, does it match the top of the stack's closing bracket? Well, if we look up what's on the stack right now, it's a open parenthesis. What closes an opening parenthesis is a closing parenthesis, and this is a closing bracket. So that's not true. Well, else, then we return false, right? Because that would mean that, or it's being closed in the incorrect order, right? And the problem literally says brackets must be closed in the correct order. So if it doesn't match the closing bracket, right, then what that means is it's not obeying to the order. So you get this far, right? So you might be thinking, boom, this is perfect, right? It's not done yet, right? So why is that, right? So if we take the code that we just wrote, right, and let's just use a case like, let's use this, right? So you have two square brackets and an opening curly brackets. Let's run through this. Iterate through the string, right? And for now, we're going to make a fake stack here, right? And we're going to say iterate through the string, right? So we're on the opening square bracket right now. If it is an opening bracket, add it to the stack. Well, it is, right? So we'll add it to the stack, right? So that's the only thing we have in the stack. Then we go to the next iteration. So now we're on closing bracket, right? Iterate through the string. It's not an opening bracket, so let's go to our next case. Does the symbol match the top of the stack's closing bracket? Well, the top of the stack's closing bracket is an opening square bracket, and the symbol that we're currently on is a square bracket, right? Those are buddies. So we'll pop the top of the stack. It's great. The stack is empty, right? And then we get to this. We said, okay, well, iterate through the string. If it's an opening bracket, add it to the stack. So we add it to the stack, right? So we make it out here, right, without ever hitting this case. So what does that mean? Does it mean it's automatically valid? Well, it's clearly not, right? Because we can see that this is an invalid string. So what does that mean? The final case, right, that we're going to need is checking whether or not the stack is empty. Why do we have to do that? For cases like these, right? So there's a couple of edge cases, right? So the edge case being that if our final character in the string is an opening bracket, right, then it means that it's not going to have a buddy, but it's also going to end the iteration, right? So we know that if everyone matches, right, the stack should be empty, right? It's like if you have, a bunch of high schoolers for a dance, if everyone has a partner, right, then no one should be standing on the sidelines. And so what we're saying with this thing is that, hey, if anyone's standing on the sidelines, right, then that means not everyone had a partner, right? So the string is not valid. And so now we can pretty much implement this. So we need a dictionary, right? We're just going to call this mapping. And I'm going to try and speed run this real quick. So we have boom, opening parenthesis, right, is going to map to closing parenthesis, right? Opening curly bracket is going to map to closing curly bracket, right? Opening square bracket is going to map to closing square bracket. And we're doing it this way because it simplifies. Let's just do two things. We can check whether or not the string is, we can check whether or not a character is an opening bracket, right, just by checking if it's in the dictionary. And then we can retrieve what its matching partner should be just by actually looking up the value, right? And so we need a stack. So let me make sure my comments are above everything. So we need a stack to enforce the order of rules, right? So we're going to say let stack is equal to this list, right? So this is just an array, right? We're going to be using it like a stack. So for this, the operations we're going to be using are going to be constant time. Well, should be. So we're going to iterate through the string. So we're going to say for let car of s, right? So we're going to iterate for each character in s, right? So we said if the character is an opening bracket. So how do we check that? We're going to say if car in mapping, right? Because our mappings are opening parenthesis, opening square, opening curly, and opening square. So if car is in mapping, it means that it's either one of these three. So if it is, we're just going to say stack.push car, right? Which is great. So else if, right? And so our instructions, our intuition is right below it. So if the symbol matches the top of the stack's closing bracket, right? So we know that the current symbol that we're on is car, right? So we need to see if something is equal to car, right? So what we need to do, right? We need to check the top of the stack. So we need to check the top of the stack. We're going to say stack.length -1. So we're going to subscript the stack, right, with stack.length -1, which is really just the last element in the array, right, which is going to get us the last element in the stack, right? But now we need to get what its matching closing member should be, which means we have to subscript this with mapping, right? So we're saying look up, get the last element in the stack, right? So let's just say we have these two elements, right? It's an opening square bracket. Let's just say it's an opening parenthesis, right? We're going to say get the last element in the stack, right? And then once you get that element, look it up in the dictionary. If we look up opening parenthesis in the dictionary, we get closing parenthesis. So is the current character a closing parenthesis? So that's how we can be very specific with what we're looking for, right? But those those who are keen will notice that our intuition also says, right, that we're gonna, if these match, right, which means we found a perfect match, right, we should do stack.pop, right? Because someone found their buddy, which is great. So if we're going to be popping off the stack, which means we're going to be removing an element from the array, right, we have to be absolutely sure, right, that the stack is not empty. And so that's another language specific. If you're in Python, you can just say if stack or whatever language you're using. So you have to make sure the stack isn't empty, and then we can also look up elements in the stack, right? So else return false, right? And so there's one more thing that's super duper important. So you might be saying stack.length does not equal 0, right? Is that important? So it's very important, right? So imagine if you have, let's just say, a string like this, right? So you get this opening bracket, this closing bracket in here, right? So you say if card mapping, it's not because it's a closing bracket, right? We're going to say if the stack.length doesn't equal 0, well, it is equal to 0, right? Because there's nothing in the stack currently, right? So we're just going to return false. So this catches any string that starts off with an incorrect curly brace, right? Square, parenthesis, or curly, right? That's also going to catch that. And so if we click run, it works. Okay, and when we can click submit, first time doing this problem, by the way, actually true. And then boom, there you go. So what's the time and the space complexity? So time complexity is going to be linear time, right, where n is the number of characters in the string, because we're just linearly iterating through the characters, right, to enforce order and return whether or not it's true or false, right? And so we have to, worst case, right, we have to iterate through the entire string to know whether or not it's invalid input string or not, right? In our worst case, right, is, where you don't have any closing braces at all, right? And by the time we get to the end of the string, that's the only time we'll know, right, that this was not a valid input string. Our space complexity, also linear space, right? Why? Because we're using a stack, right, to enforce order. So worst case scenario, right, is going to be the same as time complexity, right? We only add opening curly braces to the stack, but if our input string is, right, just an infinite number of opening brackets, right, then our input's going to scale quite linearly with the length of the string. And so that is valid parentheses.